we are in the third section. Like I mentioned, this is probably the biggest, most important section of this entire thing for this specific course. We're about to walk through the whole point of this training, right? Is how do we get a foothold, right? We talked about getting access keys. We talked about potentially like looking at public buckets and whatnot. Now we're gonna actually put that into practice, and we're gonna move on, find secrets. They're publicly exposed. We're gonna find ways to get a foothold. If I can change slide. There we go. All right. Okay, so key disclosure in public repositories. All right, I'm gonna actually pull up this site for you because it's just fun to watch. Basically, key disclosure in public repositories is something that it's a very common issue, right? But one of the things that is really important here is that if you find keys, you might be able to access the network. But let me pull up this example just to kind of show you guys how quickly this works. So I'm going to leave this running over here. Basically, okay, so this site, I have a link in the slides. It's to get, there's a G in there, .darkport.co.uk. Basically what it's doing is it constantly crawls GitHub and GitLab for tokens that get posted and various secrets. So GitHub has put in place protections to prevent this from happening. Okay, so GitHub has already put in some really good protections that if you try to push code with an AWS key, it will alert you and it'll just disable the repo, which is awesome. But for other services and for cases where maybe if you have some custom code that it can't really identify, those will just get still public. So for example, you'll see things like high entropy string, like app key base64 blah blah blah, environment configuration file, Django configuration file. And here's kind of a list on the left here of all the things that goes through. So 1Password, password management stuff, AWS keys, Google Cloud JSON OAuth keys. But basically the whole point of this, the reason I'm kind of showing you this is just how quickly it finds a bunch of things that are already out there. And this is just an example of how much stuff gets posted, right? It's very common for creds to get posted. So I'd recommend trying that out, just seeing if you can find stuff. Some tools for searching your own Git repos. So like I mentioned, with GitHub, they're already doing a decent job of preventing you from hosting that stuff yourself. So it's important, though, for you to be able to check your own repos and to search through stuff. So there's a few different tools here. I'm going to highlight Git leaks in a lab in just a second. But then there's also GitRob and TruffleHog, which are also very great tools. But basically, the key feature to kind of look for, I think, between all of these is, does it do authentication? And the reason for that is you want to be able to authenticate to private repos, right? You want to be able to authenticate and search through repositories, code repositories, that you've gained access to, either through getting a credential, or maybe it's an internal repo. But the thing that's super important here is commit history, okay? So let's say I'm a developer. I have a web application. I post my code, and I'm like, oh my god, it's got AWS keys in it. Let me change that real quick. And then I repost new code without those keys. The way that Git works is it keeps commit history. So for every single post that anyone's ever made, there is actually a commit ID associated with every single post. So the thing to look for is where somebody has posted something historically. And that's what we're going to do in the next lab. If I can change slides. There we go. So we're going to pillage Git repos for keys. All right, so the goal here is to try to identify a repo that we want to attack, which may be public. It may be, so during your recon, this is something that I would say spend a good amount of time looking for too, is look for public-based code repositories by employees at the company. A lot of times you can find those by just Google searches. And then search those, as well as if you get access to on-prem, these same techniques apply because they'll help you find any previous commit history. So I'm gonna use git leaks. This is the tool that we're gonna kind of walk through here. The cool thing about git leaks is it's written in Go. It's really fast. BB and I were joking the other day because it actually lists out how fast it runs down to the microsecond. And then it's got a Docker image, which makes this lab super easy to set up. So let's go back to the Kali VM. Let me cd back here. I think I already downloaded it. Maybe not. Okay, so let's go ahead and pull the Docker image. So if you guys installed Docker, it should just be as easy as sudo docker pull zrice the zav / gitleaks. Now, the reason I threw Docker in here was kind of twofold. I could have used Docker for the last lab as well, but I kind of wanted to just give an example of how to use Docker, because Docker is it's kind of like a good cloud-specific thing to use anyway. The cool thing about Docker is it builds everything into these images that you don't need to worry about all the prereqs for installing certain tools. I mean, they work as kind of like little micro VMs, which is just really sweet. Okay, so let's get some help information because we don't know how to use the tool yet. So the command is going to be sudo docker run --rm --name gitleaks, and then the name of the gitleaks repo, and then just --help. And that should give us the help menu, which helps us understand a few things, right? So we can understand that we can use username and password for git repo. We can understand that we can look for access tokens if we want. But in our example, we're going to do a super simple search of just the git repo itself. Because, so in this git repo, in the gitleaks repo, he's got a ton of examples of places where this tool actually finds secrets. So if you run gitleaks against the gitleaks repo itself, it will first clone the repo down to your system, and then you can see it's just scrolling through, finding AWS keys, finding secret keys, finding all kinds of examples. That this is a good example of some potential things you might be able to find if you search other public repos. These are all examples, like none of this is like real stuff, right? But the thing here is that, like, it not only gives you the offender, right? So it tells you like what is the thing that it found, why did it find it, and also gives you the commit ID, so you can go find the exact commit where the tool found that specific instance of a key or whatever. So let's give this just a minute or so to finish up. And I'm going to go and open a browser because we're going to navigate to the repo next and kind of look at specific commits. So like I mentioned, like this is really good, especially if you have access to a private repository. Like I find, I don't find a whole lot of public ones anymore that have keys out there. It still happens, but in I guess like in practice, right? Like in practice on actual pen tests, private repos tend to have more secrets than non-private. So again, we're just going to let this finish up. It takes a minute. All right, so let me show you the slide here real quick, and I'll kind of show you what it looks like once we're done. You can kind of see as it's scrolling through all these commits. I mean, it's got a ton of stuff. I mean, if you run this against, like, for example, Mail Sniper is another repo of mine, right? So if you're running against Mail Sniper, I don't think I have any access keys in there, but I ran it earlier and I found a ton of just like false positives because it sees certain strings of data and thinks that they are like keys and whatnot. It thinks they're like secrets based off of just like certain strings. So you might get some false positives. I would recommend just kind of going through each one and looking for specific that you think might be extra key. This is taking a lot longer to run than I thought it was going to take. It's a big repo. Lots of offenders. But basically what we would do is next take this URL, right? And then you throw the Git account name in there, the repo name, and then the commit and the commit ID. So there's a commit ID attached to each one of these findings that we can grab. So like, let me see if I can catch one real quick. Oh, no, it's too fast. It's too fast. Here. We'll just pretend like we got one and I'll move on. How about that? I'll show the screenshot here. So it looks like this, right? So let's say that we found a commit ID that we want to look at. You can throw it in the URL, and you get directed straight to that leak, right? So that you know exactly which ID it is, and you can go analyze it more and get a better idea of what it might be used for. Okay, password attacks. Password spraying is probably my favorite thing. I think it's probably a lot of you guys, especially the pen testers that are on, probably one of your favorite things too, just because you guys know how successful this can be. Because people just don't understand that Spring 2020 is a bad password. It's one of those things that, I guess let me back up a second, because I know there's probably some explanation that needs to be done for what password spraying is. So password spraying differs from password brute forcing. So traditionally, password brute forcing is one of those things that where basically you're taking every single username, or I'm sorry, every single password combination you can think of and trying it against one username. That's your typical password brute forcing. The problem with that is that most systems have a lockout policy, right? So a lot of times you have 5 attempts in 30 minutes equals lockout. So how do you do that against a system that has that? Well, password spraying has become this thing where now we're not doing all these passwords against one account. We're going to do one password against every account. So let's say during our username enumeration, we got like 3,000 potential usernames. We're going to try one password. We're going to try Spring 2020. We're going to try company name 123. We're going to try, what else? Password 123. We're going to try all these common passwords that people pick that fit the default password policy against everybody. And we're going to try it once so that we stay out of that lockout window. If we try to attempt more than 5 or whatever the window is, we might lock out a bunch of people. But if we try one, and let's say the window is 30 minutes, one attempt against everybody, then you're not going to lock out anybody, and you're going to get like 3,000 attempts in, which is honestly like it's a very successful attack. So how does that translate over to other attacks, right? So you have credential stuffing, which is the other very, very successful password attack because people reuse passwords. We find all the time that people share the same password across multiple accounts. We recommend using something like a password manager, like some 1Password, LastPass, like that kind of stuff, to manage your passwords so you have a different password for every single website. However, we are finding that, we're finding like people reuse their passwords even on corporate accounts. So the whole password stuffing thing is whenever you have somebody that, like, let's say that they're part of like a public website, that public website gets breached, that credential gets dumped to the internet somewhere, which happens all the time. Like a few years ago, like 5 million credentials from LinkedIn were dumped. We take those breaches that are publicly dumped and then try those credentials against websites, and we try iterating them again. Like a lot of people just use the same password but then add a number to the end of it. Okay, so specific to Azure password spraying, we talked about this login.microsoft.online URL earlier whenever I was talking about username enumeration, and this is something that is pretty new. This is part of my MSOL spray tool, which is one of my go-tos for actually like doing password spraying against Azure at this point. And so this is just a web request to kind of show you what it's doing. I mean, all this is doing is a web request. And the thing is that we're hitting the graph.windows.net API here, and we're using a client ID. Oh, let me back up. We're using this client ID. So the client ID, this is specific to PowerShell, okay? So the thing is that a lot of applications have various permissions to impersonate users on Azure, which sounds like a kind of a weird, complex permission problem. But what that means is that, like, for example, the PowerShell client, which utilizes this client ID, can authenticate you as a user using this user impersonation permission to the Graph API. And there are multiple other clients that also have that same user impersonation permission. So, like, for example, my spraying tool will show up as like access via PowerShell command line in Azure. Like if you look at the logs. But if you change the client ID to one of the other services, like there's one for 365, there's one for SharePoint, it'll look like the user's just straight up authenticating from one of those. So we're going to use MSOL spray to do this. We're going to do this. We're going to do a password spray, and the script logs a ton of stuff because that endpoint is just so verbose. So that endpoint will tell you if a username is if a user cred is valid, first of all, right? Like that's the most important thing, right? Is it an actual valid username and password? It'll tell you if MFA is enabled on the account. So if it's using Microsoft MFA, it will straight up say, hey, like actually the screenshot that I have here, due to a configuration change, or because you moved to a new location, you must use multi-factor authentication access. It'll tell you if the tenant doesn't exist. So if you try a domain name that doesn't exist on Azure, it will straight up tell you. If you try a username that doesn't exist, this is our username enumeration problem. It'll tell you if the account is locked, if the account is disabled, password expired, and so on and so forth. Let me open up something real quick and show you guys just how many other things, because like I have like 10 or so different responses that I've seen. They come back on the tool, but there's so much more other data you can get. Let me see if I can make this bigger so you guys can see it. Okay, so this page here, and I'll paste it in Discord. You guys want to look at it? Basically shows off all these different error codes that come from this endpoint. Okay, so now if you start looking through the error codes, you can see that we have a ton of different information we can gather depending on the configuration of the user. So yeah, everyone give Microsoft Server some hugs. Thanks, Marcello. But like, for example, like if we look down, like not allowed tenants, authentication failed, we can get a ton of information. There's some conditional access stuff in here that looks really interesting. Like conditional access failed, bad device state, which that might indicate, like if you're trying to authenticate as this person, that you don't have the right device. Like they're only allowed to authenticate from a certain device. Like there's just so much information and other codes that we can look at on this endpoint. Anyways, if you want to do some research, that'd be a good place to start. Back to slides. And I think we're going to jump into the lab, actually. Yeah, password spraying lab. Okay, so our goal here is to perform a password spray against a list of target Microsoft Azure users. In this one, we're going to simulate kind of like, on our own what a password spray would look like. That way, I had you guys set up your own Azure accounts. That way you can spray your own account as opposed to like having, 1,000 people spray my account. I feel like that would be a bad idea. But yeah, so basically that's what this lab's going to entail. We're going to use the Windows lab or Windows VM for this one. So let's go ahead and spin up your Windows VM if you want to play along. Let me grab that. Yeah, so that's Brian, like what he mentioned on Discord. Please do not spray anyone else's account. It's a very, very important thing not to do. Only spray your own account, except I'll give you one exception here in a second. Okay, so we're going to want to open up a browser first. Let me do that so we can go grab MSOL spray. Is there something like Azure AD error codes for AWS and GCP? I am not aware of that so far. If there is, I would love to find it. Microsoft is super verbose. They give you a lot of fun data. Let's first go to GitHub. Specifically, we're going to go to my repo, so /daptac. Oh god, we're going to have a bunch of people hitting GitHub too. Ooh, PowerShell is wget now though. I see that, nice. Well, maybe we're going to go there. This is not looking great so far. Wow. Oh, it's loading. It's thinking. It's thinking hard. You would think that I would have downloaded the script beforehand, but no. Oh man. This is so slow. I apologize. I named my test users red shirt. That's awesome. Okay, so once you get to the repo, basically what you just need to do is click the MSOL spray.ps1 file. Oh yeah, like Brian, like what you said, it's just an alias for invoke web requests. Yeah, that makes sense. And so we're going to want to click the raw tab. That way we get the raw PowerShell script. And then I would just Control A, Control C, open up Notepad. VM is not happy. So we'll paste that in a Notepad. We'll save it. All right. I'm going to save it to the desktop. That way it's just easier to find. I'm going to save as all files. That way it doesn't add the .ps1 to the end of it. You know, you call it whatever you want, but I call it MSOL spray.ps1. Easier to remember that way. And now you can kind of get rid of your browser window and the Notepad window. One other thing, actually, you know, we do need the Notepad window still because we're going to create a list of usernames to spray, okay? So this is where I give you permission to test these accounts that don't exist of mine. So I have the domain glitchcloud.com. This is a domain that's hosted on Azure. So you'll at least be able to see results of accounts that exist, or I'm sorry, tenant that exists, account that does not exist. So you can use like, you know, any test names at glitchcloud.com. But then what you're going to want to do is you're going to want to throw in your email address of the account that you signed up with. Okay. So this is your Azure AD user. So I had you guys specifically set up not only the primary account, but I also had you guys set up this Azure AD user that is a member as well, that has subscription. So in my case, like I've got the intern at conceptmotionsecurity@gmail.onmicrosoft.com. So the whole concept motion security thing is my throwaway Gmail that I give to vendors that I've done for years. So it's kind of my throwaway account anyway, which I'll burn after this very, very heavily. Okay, so we're going to start a new PowerShell window. Like I had you guys pin it, so it should just be a click away. But if not, try to open it from the start menu. And then next, we need to just basically change directories to where you downloaded the script, which in my case, I downloaded it to the desktop. So cd desktop, we're going to import the module, which should tap complete. And then to spray, it's as easy as just invoke MSOL spray, give it your -user list, and then you give it the file name with the users that you created. So this should be invoke -MSOL spray -user list, and then give it the file name. And then you give it your -password option. And then this is going to be the password of your account that you know. So like this is kind of a contrived example, right? Because you know the password to your account already, but at least you'll be able to see what it kind of looks like, right? So So in my case, I'm going to use company name 123, and then we're going to click enter, and then you'll see it start spraying. And then now you see right here, this is success, right? So we'll see that we have the intern at Constant Motion Security is success. So that's a successful password spray. Don't spray my account, please. But basically, like, this is just a good example to kind of show you that, you know, the user blah 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 doesn't exist. If you throw a domain in here that doesn't have a tenant, right, then you'll learn really quickly that they're not on Azure as that domain. So this is kind of a good way. Thanks, Jason, for all I heard was spray my account. No, please, for the love of God, don't do that. So anyways, there's that. So spraying is, I think that was it for spraying. Yep, that was it for the spraying lab. Let's move on to like a defense, right? So hey, blue team, here's something. sorry, there hasn't been much so far. So I found that the Azure password protection has done a pretty good job of preventing a lot of the spraying. So the thing with Azure and O365, they prevent you from creating bad passwords like Spring 2020. They get prevented from creating them as creating bad passwords. Like I tried to set that account up using the password Spring 2020, and it's like, no, we've already seen that password too many times. And that's just a straight up like Microsoft thing. But if the organization's using the password hash synchronization, then on-prem takes precedence, right? So if a user changes their password to Spring 2020 on-prem, that gets synced to O365 at that point. But Azure Smart Lockout and Azure Password Protection, these are two very cool things. So I think password protection actually encompasses Smart Lockout as well. Password protection is basically another filter of sorts on Azure that allows you to prevent users from choosing certain things like seasons, company name, and we've seen it in practice where that actually works really well at preventing users from choosing like good passwords or choosing bad passwords. Not choosing good sprayable passwords. Azure Smart Lockout is the facility that I found that actually locks out authentication attempts whenever you brute force or spray an account from a single IP address. The thing that I found is that it can be bypassed with Fireprox. So Fireprox is a tool written by Mike Felch that is really amazing. It utilizes API Gateway on AWS to basically spin up various Lambda functions so that you're authenticating or you're sending a web request from a new IP address for every single request. So that way it's basically rotating your IP addresses. So when combined with MSOL spray, what you have now is a spraying tool that hits the Azure endpoints with a new IP address every single time. Okay, moving on. All right, so we talked about getting keys from public breaches. We talked about passwords. Now let's talk about web server exploitation a little bit, because this is a very important thing as well. Because if you're a cloud company or if you're utilizing cloud assets, a lot of times you're leveraging cloud services for web servers as well. So somebody said so Smart Lockout can be leveraged as a denial service. No. They're locking out your IP address. They're not locking out the accounts associated with that IP, with that spray. If that makes sense. So I mean, with any authentication, you have that potential, I think, right, to lock out accounts, especially like on-prem, right? Like so on-prem Active Directory, if you spray everything, you know, within that window multiple times, you're going to lock out everybody. But in this case, it's not actually locking out the users. It's locking out your IP address that you're doing the spray from. So, all right. So web server exploitation is a big topic. Go to BB's training to learn more about web app hacking. But just some generic things to look for. Out-of-date web technologies, obviously, like with some known vulns. That's one of the key go-tos for finding ways to get access to something. SQL or command injection vulnerabilities. These are probably more important for the cloud context, because the second we can run commands on a cloud-based asset gives us a lot more opportunity. And honestly, server-side request forgeries. So the ability to have a request sent on the server itself to what is known as the instance metadata URL, which we'll talk about in just a few, is super important to hacking clouds. So the metadata service is something that pretty much every VM-based instance environment has. But we'll talk about that. So a good place to start post-shell, like I said, hit that metadata service, look for certs, look at environment variables. Sometimes I've found that environment variables contain passwords. Look at storage accounts. So things like S3, like after you get access, try to utilize the account or the IAM credential that you can get from the metadata service to access S3 to look for more interesting data. So this is something that I haven't seen in practice, but I have heard of this existing. Basically, the idea here is that within Azure, within EC2, you have the ability to provision SSL certificates and store them and manage them. And so the idea here would be that I utilize an SSL certificate not only as something to sign the web traffic, but also to manage authentication. So in Azure Service Management, you could use a management certificate to authenticate to Azure. Okay, so to actually authenticate and log in to run various things in Azure. Where that comes into an interesting possibility is if the organization utilizes that same SSL cert on a web server. So now you compromise a web server. You extract the exportable key, because Mimikatz can export non-exportable keys for you, certificates. You extract it. Now you have a potential private key for authenticating. Not only just like sniffing like data that's being sent to the server itself, but also the ability to authenticate to Azure directly with that certificate. Okay, this is a pretty big topic. The AWS Instance Metadata URL. I'm going to talk specifically about AWS, but what you need to understand is that all three services have their own metadata URL. Now, what this is every single time you spin up a VM or an instance in EC2, they have to have a way to kind of orient themselves in terms of IAM permission and roles. So you can specify that an EC2 instance has certain capabilities like provisioning different access, deploying different things, just like you can a user. And the way that they orient themselves is by setting up this metadata server. It's straight up a web server that's hosted on the non-routable IP address of 169.254.169.254. So these are web servers that get stood up on your EC2 instances, on your Azure VMs. And oftentimes you can query these for IAM credentials. And basically what you can do there is get like access keys straight from this metadata service. Like that's basically what this whole thing boils down to. It should only be reachable from the local host, right? However, you compromise a server, you can reach it. If you find SSRF vulnerability, so server-side request forgery, you might be able to query it remotely, without even having a shell on the server. We're going to talk about a case where that happened right here. So the URL that you're going to want to look for is at this IAM/security credentials endpoint. This is a place that will kind of show you any IAM roles that you might have, and you can potentially hit it to get those access keys back from it. I will also note that it's possible to do this from if like somebody has set up like an Nginx proxy that allows for hitting the local host on AWS. So like this is an example I saw that basically you could curl and point the -- proxy option at a vulnerable domain, right? That's hosting Nginx proxy. And then it's actually directing that request, it's proxying that request to the local host URL, hosting that metadata service. So you're basically remotely proxying your cred to the local host of the VM or to the instance, asking it for those credentials. So there was the Capital One hack that occurred that basically what I think has been publicly released as the way this happened. I mean, I've seen it in multiple blog posts now, that the attacker exploited server-side request forgery on EC2. So they basically they remotely had an SSRF vulnerability in EC2. They were able to access that metadata URL to get IAM credentials, and then use those IAM credentials to dump S3 buckets that contained like 100 million individuals' data. It was like, I have a note here, 140,000 social security numbers, 80,000 bank account numbers. By basically being able to query that IAM credential. So AWS wanted to fix this. And so they came up with this EC2 Instance Metadata Service version 2. So there's now a new version of this. This just came out in November 2019. And basically both V2 are enabled by default, but V2 actually puts on a few different protections to try to prevent people from doing that exact thing. Okay? So it added session authentication to the endpoint. And basically the way it works is like you have to send a put request to the instance metadata URL first. And then that's responded to with a token. And then that token can then be used to query the data. So like a couple things that they did is they made it so that like for reverse proxies, any of those cases where like it adds an X-forwarded for header, which most reverse proxies do, like Nginx, if the request contains an X-forwarded for header, it just won't issue a token. It won't issue a session token. So still probably not foolproof, but it's pretty new and should help some if you're on the blue team side. Make sure that you've at least got version 2 enabled. We got, let's see, 6 minutes until a break. I think we can get through this section. I think so. Okay, so phishing is still the #1 method of compromise. You know, we've talked about hitting external resources a lot, and I can't like avoid the fact that phishing is still, you know, a super important topic to talk about. The biggest difference is we're going to start pivoting our phishes directly at developers and cloud engineers that, you know, are the ones that are utilizing these services. Because so the thing is like, if we get a credential of a typical just like 80 user, O365 user, a lot of times those people don't have access to subscriptions. They don't have access to any of the resources within any sort of cloud infrastructure. So it really takes targeted phishing at this point to phish somebody that's an engineer of something that we would actually want access to. I mean, it really involves having a subscription attached to a user. But like, I guess like a really good example is this, right? Like, let's say that you compromised an Azure credential. If that account doesn't have a subscription, there's not much you can do with it other than like use the MS Online module and maybe like query the other Azure AD users in groups, which is still it's useful, but you're not actually doing anything within Azure of sorts, right? So we're going to talk about 2 different primary phishing techniques, right? We're going to talk about cred harvesting and session hijacking, which kind of encompass into the same boat. And then we're going to talk about remote workstation compromise. So actually trying to get a session on somebody's system. So for session hijacking, it's an attack that's designed to steal credentials, right? And session cookies. This is something that, you know, we're going to try to send a phish. Maybe we'll make it look like they need to authenticate to some service that we want, you know, to get a cred. But the good thing about this attack for us as external attackers is that we don't really have to rely so much on bypassing endpoint protections, because this is something where the user's just using their browser and hitting our link and trying to log in. So we email a link, we clone an auth portal, something like Microsoft Online, G Suite, AWS, whatever we're trying to get access to, and then they go to our website, which we make, the domain name is the main thing that we have to really kind of like make look good, because the rest of it just gets handled for us by tools like EvilGenX2 and Modlishka. These tools basically are reverse proxies of sorts of the actual website. So when you visit it in your browser, you basically are looking at the typical like Microsoft Online portal. And really, if you looked in your browser, in your URL bar, you would see our domain name that we're pivoting to the actual site. And the second somebody logs in now, we not only get credentials, right? So you get clear text credentials, but you also get the session data. So this is where this is really important, because this allows us to use that session token in our own browser and be authenticated as that user. And the other thing here is that this can help us evade 2FA, right? Because the user is literally logging into the same portal they're used to logging into every day, except now, whenever they do, they get their prompt for 2FA, it's still going to the backend server the same way. We're just right in the middle of it, and that allows us to ride the user session even if they have 2FA. This still, persistence is necessary, because this means that we have to work quickly because of potential session timeouts. If they catch on that we fished them, then they might try to end their sessions. There's a lot of reasons why we might look at persistence really quickly, but like I said, again, next class is deep dive into persistence and Prevesc. So calendar event injection, we talked about this briefly a little bit ago. This is something that Mike Felch and I worked pretty heavily on a couple years ago. Basically, the gist of this whole thing here is that you can inject calendar events into Google Calendars. So from a phishing perspective, this allows us to do things like make an alert pop up on your phone, right? Which is kind of a different attack. A lot of people are starting to get way more aware of email-based phishing, right? Like a lot of people are of the idea that, oh, I got this email in my browser or in my Outlook client, I should be more careful with that. But the second somebody gets an alert on their phone, they're not usually too cognizant of the fact that that might be something malicious. And the good thing about, or I guess the good thing, the interesting thing about this specific attack is that it silently injects, meaning that we don't have to send an email. You can use the Google API to inject events into anybody's calendar we want. And this is one of those things that they didn't really think was a problem. And we could also mark it as accepted. So you get this alert on your phone, and it says, hey, you have this urgent meeting with your boss, and you're like, oh man, I didn't realize that I had this. I better check the agenda that's attached to it real quick. And so we created a link to an agenda that is basically just a link to our EvilGenX2 phishing page, and creates that urgency, creates that notification, so that we can phish them. So it's 3 p.m. I think it's probably a good time to take a little break. If you guys want to take a quick 10 minutes. There's Jason. Jason's back.
Hey, Beau. You've been talking for 3 or 4 hours. Do you need 10 minutes, or do you want to answer questions?
I think I'm good. I think I can answer them. Let's do it.
Okay. I'm going to drop a question into our chat that we get to look at. And then, because it's kind of long, and if you can read that, it says the example command. Do you see that? If you could read it out loud, then.
Yeah, okay. So the example command was for the S3 bucket enumeration lab that we did. And they're saying that, number of buckets that are listable 34, So which one is glitch cloud pointing to, and how do we list the other 33 buckets? No, so that's the thing, is like the bucket gets replicated, right? Across multiple regions. If that makes sense. So like you don't have to worry about the region in this case.
Okay. All right, next question. Can you explain the non-exportable certificate again, please?
Yeah, sure thing. Okay, so with most TLS certificates, whenever you generate them, you mark them as non-exportable, meaning that most typical users shouldn't be able to export them. Meaning, like, you can't export the private key portion of that from a public key or from the key that the actual backend endpoint, right? Because it prevents issues, right? Like, because if I can export the key, I might be able to go and install it somewhere else. I could use it to decrypt traffic, which is a super fun attack too. if you get a private key for an SSL cert, you can decrypt web traffic to that server if you can man in the middle of the traffic. So that's why this whole exportable thing is important, right? Like, you shouldn't be able to export the private key. However, Mimikatz has the ability, if you have root access to a web server, to export private keys.
All right.
Next question.
Does calendar injection work on iCloud?
So iCloud is the storage for Apple, right? I mean, is iCloud I'm not an Apple guy, so is iCloud a calendar service? I mean, this is only Google, so I don't know.
Yeah. Maybe we can get some more information.
Yeah, this is BB. iCloud is like Apple's. I almost said that, like their Azure. No, it's how Apple syncs things for your accounts for different devices. So there is a calendar. You can store your calendar in iCloud, and then you see the same one on your Mac and on your phone and on your iPad. It uses the iCalendar format, so potentially, I mean, it's got all the same inputs that the Google Calendar has, but I don't know that anybody's tested to see if the injection works there.
Yeah, that'd be good to test. I mean, so it will inject into a Google account, if that makes sense. So if you're using Gmail, if you're using Google Calendar, that's where this is a specific thing, right? If you're using iCloud to connect to a Google account, then you should get the injections as well.
How do lockout settings vary between the Azure authentication mechanisms?
So lockout settings is specified by that password protection service that I mentioned. So I actually don't know what the default is. I think it's like 10 or maybe attempts or so. I know that there is some differences that occur whenever you have hybrid environments, because one of them takes on-prem over the other one. And one of them takes precedence over the other one, meaning I think the on-prem policy takes precedence over the cloud policy. So, like, for example, if you had like an on-prem policy of like 10 attempts or something, I think hitting the cloud service 10 times will lock that account out, I believe.
There was a comment from someone, would it be an idea to create a webinar question channel? Live chat is too crowded. We've had multiple channels before, and what happens is people just pick one, and then we have to monitor like 4 or 5 channels. So what we've done is simplify it down to live chat, and that's made it as simple as we can. So we have GoToWebinar, we have Discord, and we do the best to monitor both. But there was one day when there was like people used like 8 different channels. We couldn't find anything, so simplified it to one. Could you please show the cloud enumeration command you typed on Pacu, P-A-C-U, at the beginning of last session?
Cloud enum. Let me see. Is that? So I think that was the cloud enum tool, I believe. Let me go back.
There's some people answering it in the Discord by like pointing to the slides and such, but just in case.
Okay, let's see. Yeah, so it was just Python 3, Cloudinum, pi-k, and then the name of the company you want to check.
All right. And then someone had, there was a question about your 16-hour class about it being tool use and theory and labs. Like, what is the balance for the class?
So I try to make it 50-50. I think a lot more of this one ended up being a little bit more theory than tool driven. I think that the next, so I finished up the persistence and privilege escalation one, and there's some pretty long labs in the next one, because some of the setup is just, it's good to do and like on your own, so that you can kind of learn how this stuff is getting set up and then exploit it. So I think it's about 50-50 theory to technical lab time.
And then does the 16-hour class cover cloud container attacks?
Yeah, I answered that in the last one. I am going to cover it somewhat. It's not a crazy huge portion, but yeah.
That's what happens when Jason leaves and comes back.
It's all good.
Let's see, any other questions? Let's see. How long does the glitch count? For how long the glitch cloud? No, that's weird. For how long will the glitch cloud be available?
It'll be up for a while. Yeah, basically what they're talking about is I set up an S3 bucket called glitch cloud that they can hit.
Is there an index of topics covered in the class on the 16-hour class? I'll see if I can.
So we have the description, right? On the sign up page that has most of it, I think, but it's not really like an index.
And then let's see, we got 2 more minutes before we get started again.
Yeah, so I see somebody mentioned they're confused a bit about the calendar injection attack. Yeah, I kind of rushed through that, so I'll talk some more about that right now. I was trying to rush through it so that you guys could get a break on the top of the hour. But okay, yeah. So basically, the calendar injection attack. There is a tool. It's called Mail Sniper that does a bunch of things, right? Mail Sniper is not only just a calendar injection tool. It's searching OA, password spraying, a bunch of other stuff. And with that tool, we basically built in the ability for injecting events into calendars. And this is something that a few years ago, like Mike Felch and I, we released research on this a couple years ago while I was Hackenfest. And we started seeing, or we told Google about it. They said it wasn't a vulnerability. Then last year, we started seeing it heavily exploited. Like, I mean, people were like, I was watching security researchers on Twitter, like, how the hell did somebody get this thing in my calendar? I don't have an email, and I've got this event that shows up that says I want a free iPhone, and I need to go to this link. Like, how did that happen? And we were like, we talked about this 2 years ago. Like, this is calendar injection, and there's some deep research done about it. I mean, Forbes picked it up. There's a bunch of articles that kind of dove into this problem, and it's still an issue. It still has not been fixed, at least to my knowledge. I mean, last time I tested it was maybe like a month or so ago. But yeah, I mean, it's a thing. Calendar injection.